Hello everyone. In this video, we shall learn about diffusion and the temperature scale. First, we shall study diffusion, and so let us look into this activity. We take a gas jar full of bromine vapors and invert another gas jar containing air over it. Then, after some time, these red-brown vapors of bromine spread out into the upper gas jar containing air. In this way, the upper gas jar, which contains colorless air in it, also turns red-brown. And these all happened on their own, without application of any external energy. What do we call it? And why does it happen? This spreading out and mixing of a substance with another substance due to the motion of its particles is called diffusion. The diffusion of one substance into another substance goes on until a uniform mixture is formed. Diffusion is a property of matter which is based on the motion or movements of its particles and tells us that the particles of matter are constantly moving. Diffusion occurs in gases, liquids, and solids. Diffusion is fastest in gases and slowest in solids, as the particles in gases move very rapidly and the particles in solid do not move much. The rate of diffusion increases on increasing the temperature of the diffusing substance by heating. This is because when the temperature of a substance is increased by heating, its particles gain kinetic energy and move more rapidly. Let us look into these common observations. The smell of food being cooked in the kitchen, or the fragrance of burning incense sticks or agarbatti, as we all know, or the smell of perfume reaches us even from a considerable distance due to diffusion in air. Similarly, the spreading of ink or blue color of copper sulfate or purple color of potassium permanganate into water on its own is due to diffusion in water. We have also noticed that if we write something on a blackboard with a chalk and leave it uncleaned for a considerable period of time, say at least 10 to 15 days, it becomes quite difficult to clean the blackboard afterwards. This is due to the fact that some of the particles of the chalk have diffused into the surface of the blackboard, and this is the example of diffusion in solids. Actually, the diffusion of a solid substance into another solid substance is so slow that many of us think that diffusion does not take place in solids at all. Now, let us learn about the temperature scale. We use Celsius scale of temperature for measuring temperatures in our daily life, like a news anchor reporting the maximum and minimum temperature for the day in degrees Celsius. In fact, in our day-to-day life, to define melting point of ice to boiling point of water, we use degree Celsius, which is written in the short form as degree C, read as degree C. But is it the standard unit? Actually, degree Celsius is not the standard unit. The SI unit or the standard unit of temperature is called Kelvin, denoted by K. So, there is another scale of temperature called Kelvin scale of temperature, which is used by the scientists mainly for research work. Please note here that the word degree or its sign degree is not written with the Kelvin scale of temperature. Please make a note of it. Now, an advantage of the Kelvin scale of temperature is that all the temperatures on this scale are positive. The relation between Kelvin scale and Celsius scale of temperature can be written as temperature on Kelvin scale equals temperature on Celsius scale plus 273. Thus, the melting point of ice on Kelvin scale is 273 Kelvin and the boiling point of water on Kelvin scale is 373 Kelvin. We also call the temperature in Kelvin scale as absolute temperature. We have a home task for you. We all know bromine and air take about 15 minutes to diffuse completely, but bromine diffuses into a vacuum very rapidly. Give reason. So that's all from today's video. See you in the next class.